Hello everyone. Today we'll talk about the TrueFoundry MCP Gateway and how the features available within the MCP Gateway are empowering enterprises that are building and deploying MCP agents. So firstly, what is an MCP Gateway and why is it so essential? Let's take a closer look. Model Context Protocol or MCP is an open protocol that standardizes how applications provide context to LLMs. However, if every developer were to manage their own MCP servers or authorizations, it will result in chaos and security risks. A centralized MCP gateway and MCP registry help solve for these problems, and this is exactly where TrueFoundry comes in. The TrueFoundry MCP Gateway is an enterprise-ready platform that centralizes access to AI development tools using the Model Context Protocol. Instead of managing hundreds of individual tool configurations across your development teams, you can now provide secure governed access to curated MCP servers for multi-tenant use through a single platform. The TrueFoundry MCP Gateway provides an MCP registry, centralized authentication, MCP metrics for observability, and an MCP client built into the gateway which orchestrates agentic loops between LLM and MCP servers. Think about some key areas where the MCP Gateway is useful. Instead of AI agents requiring separate connections to each MCP server, AI agents can now connect to one gateway and access multiple MCP servers. The central IT now manages cloud-hosted MCP infrastructure via streamable HTTP instead of developers installing and managing MCP servers locally. There is also centralized credential management instead of scattered API keys and credentials across tools, and much more. Now let's understand the authentication and authorization aspects. A user can authenticate into the gateway using the TrueFoundry token or an identity provider, which suppose OAuth 2 and above like Okta or Azure AD. The gateway then verifies the IDP token and extracts user details from the token based on the SSO settings. The control plane handles user-specific OAuth 2 flows, ensuring users only access the resources that they are authorized for. The user's details are then mapped by the TrueFoundry Control Plane to tokens that the MCP server needs. The tokens that the MCP server needs can be of two types. They can be static, where it needs header-based authentication, think Hugging Face, or it can be dynamic based on OAuth, which is highly recommended for production MCP servers. And most popular MCP servers like Slack, GitHub, Atlassian, etc. use this way. Now let's see a quick demo on the TrueFoundry platform. What you see here is a centralized MCP registry with all MCP servers in one place. You can add public as well as your self-hosted MCP servers, which are then registered in the TrueFoundry Control Plane that keeps track of their authentication mechanisms as well. And all you need is a unified key to access all MCP servers. You can view tools by just clicking here and browse through the definitions of the tools. You can check the code snippet in popular frameworks by clicking here like Python, TypeScript, and others. You can also change the configuration of the MCP server after it has been added. Now let's understand the built-in role-based access control or RBAC a bit. When creating a new MCP server group, for access control you can mention which users should have access to the server group and what should be their role. Common use cases for this would be creating a dev MCP server group where developers have access to make changes to the servers, against a prod server group where only the admin can do that. Or you can also have the MCP server groups by project or segregated by team. Very soon we are also introducing virtual MCP servers where users can be restricted access to a subset of tools within the same MCP server. This will provide even more fine-grained access for powerful RBAC. And as you saw earlier, you can mention different authorization mechanisms when adding MCP servers, mainly bucketed into header-based or OAuth. Note that dynamic client registration or DCR is also OAuth-based, where the OAuth 2 client credentials are automatically registered with MCP server's authorization provider. TrueFoundry also offers an agent playground for prototyping and experimentation, where you can load up models from 1,000+ options across model providers. You can configure the model settings like temperature, maximum tokens. You can also connect your own MCP servers, whether they be TrueFoundry managed or your own custom MCP servers. You can set up guardrail settings, structured output schemas, or routing configurations, and perform prompt engineering in the main playground. Once done, you can save the agent session and also version it. Finally, you can also publish it as an agent app. This is a powerful feature as you can create a shareable link accessible even when the user is not on TrueFoundry, just by having someone from your SSO team configure the IDP of the user. You can also monitor the MCP performance by looking into the MCP metrics. Let's filter this for the last 30 days. You can inspect metrics such as requests per second, request latency, or error requests, and you can do this at an MCP server level or a tool level. What we have shown today is just the beginning of how the TrueFoundry MCP Gateway can transform your AI development process. By centralizing your MCP servers and offloading the tedious work of authentication management, you can move faster, reduce security risks, and give your teams the power to build incredible AI applications. We're constantly adding new features and capabilities to the MCP Gateway to make it even more powerful, and we have a lot more coming. Feel free to talk to us about it.